In this video, we will solve this confidence interval problem right here. And so we had 3 samples, and we used 2 different methods to record these 3 samples. Method A, we could say that we use a ruler, and method B, we could say that we use a futuristic laser. And so it's measuring the same thing. So sample 1 with method A gave us this number, and method B gave us this number. Likewise, sample 2 using method A gave us this number, and method B gave us this number. Likewise for 3. And so we want to know if these methods produce numbers that are significantly different at the 95% confidence level. And so let's get started. So whenever we have problems where we're using 2 different methods, we have to do something special in order to solve this problem. And so first we will construct a table. This right here will be sample 1, 2, and 3. And now we calculate the difference, DI. So essentially we're doing 11.255 minus 11.152, and we would get the difference of 0.103. Likewise, we do 2, 10.379 minus 10.111, and we would get 0.268. And finally for 3, 20.678 minus 21, and we would get negative 0.322. From here, we calculate the average. So we add up these 3 numbers and we divide by 3. And then we would get 0.0163. Next, we do another thing. So we say DI, this number right here, minus D average, this number here, parentheses, we're closing it, and then we square it. So what we're going to do here is say 0.103 minus 0.0163. We square it, and we would get 0.00752. Next, we do this one. So 0.268 minus 0.0163, close parentheses, we square it, and we would get 0.0634. Finally, the third one. So we say negative 0.322 minus 0.0163, close parentheses, and we square it, and we would get 0.114. Once we've completed this chart, we calculate the standard deviation. And in order to do so, it's a different formula. It's going to be SD is equal to the square root of the summation of parentheses DI minus D average, close parentheses, squared, divided by n minus 1. So I'll show you what this means. And so this right here will equal, so SD is equal to the square root of the summation. So we add up these numbers. 0.00752 plus 0.0634 plus 0.114. And so this is this line right here, the summation of it, divided by n minus 1. So we have 3 terms. So n is 3, so 3 minus 1. And so we would get 0.304. Next, we will calculate T-calc. And there's another formula for this. It's the absolute value of D average divided by SD times the square root of n. So D average we said was 0.0163 divided by the standard deviation, which was 0.304 times the square root of n, which is 3, and we would get 0.0929. This is the value for T-calc, and in order to determine if these 2 methods are significantly different at the 95% confidence level, we need to calculate T-tab, which is T-table. And so this information is typically given from a table. And so if we scroll up, we get, this is a table. This is a shortened table. In a real table, you'll have other information like confidence of 90%, 95%, 99%, and more degree of freedoms. And so in order to calculate the degree of freedom, it's n minus 1. So 3 minus 1. So it's 2. And so 2 would correspond for T-tab as 4.303. So we'll write that down, 4.303. And so we can say that T-calc, this value right here, is less than T-table or tab, because 4.303 is greater than 0.0929. And whenever we have something like T-calc is less than T-tab, the answer is not significantly different. And we're doing it at the 95% confidence level, so we say at 95% confidence. Now, had T-calc been greater than T-tab, then it would be significantly different. And that's all we need to do for this problem.